Good morning, good afternoon to everyone joining. Thank you all for making it, depending on where all around the world you may be. Really happy that you've been able to take the time to join us this afternoon, this morning, wherever you are. So my name is Dan. I'm the Content Marketing Manager at Picterra, and I'm very pleased to be joined by both Dimitri Bach, a Scenario Creation Analyst at Safe Software, and Lucio Colaiacomo, who is the Chief Technology Officer at the European Union Satellite Centre. And today is all about looking at how we improve the accuracy and the availability of spatial data with artificial intelligence and FME. Now, I'll go ahead and let both of my fellow speakers introduce themselves. So please, Dimitri.
Hello, everyone. So I'm Dimitri. I have been with Safe Software for 18 years, doing all kinds of interesting scenarios. When I just joined, we added raster support to FME, then point clouds. In 2015, I played Minecraft for a living for a year, because for us, everything is just data. And then around 2019, I came across Picterra and tried it and really loved my experience, and I built a connection and an integration between our two platforms. So, and well, this is why I'm presenting here today.
Fantastic. Thank you, Dimitri. And being able to play Minecraft for a living certainly is the dream. Lucio, please introduce yourself.
Hey, good morning, afternoon, everybody. I'm Lucio Colaiacomo, CTO at the European Union Satellite Centre, working here from 25 years now, and dealing with technologies at all level and trying to improve the efficiency and the workflow of the SatCen through these new technologies or coming technologies. Basically, I'm dealing with standardization and introduction of new standard at SatCen. So that will be the more or less the goal of my presentation. And thank you to join this meeting. And I leave you the floor. Done.
Perfect. Thank you, Lucio. Great to have you both here. So thank you so much for joining us and your time today. So we've met the speakers. Let's check out the agenda. So Dimitri, please, if you could just advance to the agenda. Fantastic. Thank you. So after the brief introduction and the welcome that we have for you this morning, I'll be giving you a very quick overview of the Picterra platform. I'll then be handing over to Dimitri, who's going to be running through the integration we have between both Picterra on one side and Safe Software FME data integration platform. He's also got some great demos to share with you today. No Minecraft demos, unfortunately. We'll leave that for another time. But he's got some really nice demos to show how you can do this in action. We'll then hear from Lucio, and he'll give us an introduction to both the EU SatCen itself, but also a very special use case that they have, a real world use case that shows this integration between the two platforms in action. And we'll finish with a 10-minute question and answer session. So please, if you do have any questions throughout today's session, please pop them in the chat box, and you'll see that we have a specific person. So if we have any questions, ask me as the host. So please do make sure that you're sending any questions to that user within the chat panel. And to answer a very frequently asked question that we have during these sessions, yes, you will receive the recording, so don't fear. And yes, you will receive these slides along with any supplementary resources that we're going to go through today for your further learning. So let's dive in. So who are Picterra and what is our platform all about? Well, essentially founded in 2016 in Switzerland, we help our clients worldwide solve some of the most challenging geospatial problems. Now, this may be around tackling climate change. This may be overcoming the challenges of digital transformation by leveraging the latest in AI and geospatial tech. This may be ensuring safety, mitigating risk. But it also might be empowering people and driving social impact. So we help our customers, we help our clients future-proof. We help them scale their business and support a transition to a decarbonized economy. Now, of course, our platform works on Earth observation imagery, be that from a satellite, a drone, or other aerial sources. So with access to more of these images than ever before, companies across a very wide range of industries are realizing the strategic importance of this data, even ones that traditionally never saw a use case for this type of imagery before. Now, this screen you're seeing now shows our platform in a nutshell. It enables you to train, deploy, and manage machine learning models that power geospatial apps and services. We enable you to build scalable geospatial products with our MLOps platform. Now, this is an entirely cloud-native platform. You can manage all of your data in one place by creating, training, and improving your deep learning models in an extremely collaborative environment and bringing them production without needing any additional resources from IT. Now, over on the right-hand side here, you'll see that with that built-in support we have for APIs and plugins, there's many options to build custom dashboards for clients or continue processing in other GIS software, be that including support for Esri, ArcGIS, the open source QGIS, and also including, of course, safe Software FME, which we'll take a closer look at today. Now, we enable new use cases across many, many industries. So we're actually reshaping how entire industries operate, and we're transforming our relationship with the Earth by enabling this collection, this processing and analysis of geospatial data. So professionals across many different types of industries can use our machine learning platform to drive this change at scale. So a few examples that you can see on screen now. In the forestry, the carbon market space, looking at preventing deforestation, monitoring carbon stocks, preserving biodiversity. In agriculture and regenerative farming, crop monitoring, classification, land mapping, field and farm boundary mapping, and livestock monitoring. Within the mining space, we can look at water body detection, crack and erosion localization. We can even do things like mapping weeds and doing mine rehabilitation and revegetation monitoring. Now, we also extend to other use cases like in the government, international institutions and local institutions. So if you need to do any critical infrastructure monitoring, public asset monitoring, or natural disaster response. You know, the sky, pun intended, really is the limit here. So whatever you can detect, whatever you can see within a satellite, a drone, or other aerial image, you can build a deep learning detector in hours. Now, all of this enables you to answer these sorts of questions. Now, these are real world use cases from some of our clients. But for example, how many carbon credits can I harvest? Asset management is a very popular one. So are the reported vehicle counts correct? And you'll see in this screenshot, not only can we count vehicles as a whole, but actually with a multi-class detector, we can look at the individual models of each of this manufacturer's lineup. And a big one in terms of biodiversity and sustainability, this is an FMCG company that wants to ask the question, you know, are farmers growing coffee in a biodiversity scheme in a sustainable manner? Are they hitting their KPIs? So these are just some of the questions that you can answer by using Picterra. Great thing is, those of you new to Picterra, and I thought a lot of you in the room today answered they were new, can get a free trial of our platform at picterra.ch. But what we really want to spend some time on today is looking at the integration into your data workflows. So at this point, I'd like to hand over to Dimitri, and he's going to take you through an overview of the integration between SAFE, Software FME, and Picterra, and show how you can make object detection part of your data workflows, being able to detect objects, being able to detect change and patterns at scale. Thank you, Dimitri.
Thank you, Dan. So for those who are new to SAFE software and our product FME. We are enterprise integration platform. And basically our goal is to remove all the barriers that you have in bringing all the data you have across multiple platforms, maybe across multiple organizations together, delivering where it needs to be in a form that it needs to be. Safe Software started around 30 years ago, and we have thousands of customers around the world. We have an extensive network of partners, and partners of different kinds. We have value-added resellers, for example, and we also have technical alliances, like we have with Picterra, where we basically recognize that our technologies complement each other very nicely, expand our reach and our capabilities. So that's why we build this partnership. At Safe Software, we, with our product, we support multiple data types and hundreds upon hundreds of different formats. So it started with CAD and GIS in 1993, 1995. Then we added databases, XML, rasters around 2005, and I just joined 3D data, BIM, including Revit, and so on. You can see here so that Picterra fits into several categories. It's of course raster data, it's web because we talk to Picterra through its API, and it's also AI and machine learning part. So it's a really nice integration going into multiple destinations or coming from multiple sources. FME, it's a product that consists of two main parts. FME Desktop, it's a product where you, our customers, our partners, design the workflows. You decide what data sources you have and how you need to change them while they are moving from where they are to where they need to be. And you can change them in every possible way. Yeah, so you can bring as many different systems together in a single workflow, CAD and GIS and maybe rasters. You can clip them, you can tile them, you can merge them, you can change attributes, you can see what relationship they have spatially or by joining them by attributes. You can reformat your attributes and so on. Then we have FME Server. It's a great way of scaling your workflow to an entire organization. So if you have this workspace on the left, you probably don't want everyone on in your organization to mess around with this, and maybe it's easier if you can just give maybe a nice web form, or maybe use this workflow as a part of your own application to your customers or to your colleagues to run the workspaces easily and without even looking at what's behind the scenes. FME Cloud, it's actually just a hosted FME server, and it means that you just don't have to install it on premises. It just lives in the cloud. But from a customer point of view, in this case, I'm of course just like a customer or a user. There is no difference between FME server and FME Cloud. They have a couple of mobile apps. One is just allows FME Data Express allows accessing workspaces that live in the cloud or on an FME server, and we also have an augmented reality app. Yeah, I played with that a lot, so it's sort of fun. But how we actually can integrate these two platforms? I'd say in two ways. First, we can open Picterra to that multitude of formats that FME supports. So we support 450, maybe 500 different formats, and a lot more if you talk about versions of XML or web protocols. So we are at that stage. It's hard even to count how many formats we support. We can help Picterra to read those data sources. And then once Picterra produces some results, we can help delivering that results to, again, multiple platforms or maybe national standards. And another way to interact with Picterra is through Picterra API, where we can run detection directly from FME without leaving it. So one part I still leave to Picterra. So training, it's an interactive process, and FME is all about automation. So you would still need to go into Picterra environment and maybe train your model there. But after that, you can take everything to FME and run the whole process from within FME. So a little bit more details about how we support this integration, these two parts of integration. So as I said, we support multiple formats. So probably over 50 different raster formats. Not all of them, of course, would make sense for Picterra, but a lot of them will do. And of course, we can just, you just would add your ECW image and send it to PicterraConnector, and it will just work inside Picterra. Then you can bring any vector format that we support. That's a lot, believe me, including national standards. So Picterra is a Swiss company, and we, for example, support Interlist, which is a national standard in Switzerland for vector data. And what you can do with that data, you can, for example, create detection areas. I will show how it works later. Turn them into GeoJSON and submit to the Picterra through FME. We don't limit you to just rasters. For example, if you have a point cloud, especially colorized point cloud, you can rasterize it and again use a normal image inside Picterra. Or you have an archive of PDFs with embedded images, so we can read PDFs and actually write them, extract images from there, and then maybe run Picterra on those images extracted from PDFs. And once you get your results from Picterra, again, you can take it and transform to hundreds of formats. And then within FME, you can transform 2D data to 3D. You can, maybe make some overlays of different data sources, combine them together, and deliver to the destination system where it needs to be. When we speak about raster support, there are many transformations that will help you optimize your raster imagery. For example, if you know, satellite imagery often comes as separate bands of 16-bit separate images, single band 16-bit. You can combine them together and build your RGBA images or RGB images, and you can change interpretation from 16-bit. You can go down to 8, so that at the end you would produce an RGB24 to save on bandwidth, and maybe you just don't need such a rich, bitness in your image. You can also apply raster algebra, for example, because as you know, again, satellite images come, they measure or store as much light as they receive from sensors, and it means that you can have very dark image where you see nothing, but you can apply some raster algebra and increase the visibility of the image. Then sometimes you can have huge images. You don't need them to send again to Picterra. You can clip to areas of interest. You can tile your data. You can reproject using again various reprojecting engines. And again, we have Swiss reprojection engine within FME. A second way of connecting to Picterra is through PicterraConnector. This is a custom transformer. I will speak about transformers a little bit when I show you an example. It's a custom transformer that talks to Picterra API and can perform different actions. So you can list your projects, your rasters, your detectors. You can upload images through this transformer. You can run detection and download results. So the most interesting part, of course, is automation of all these processes that you would develop with FME desktop. What is interesting that you can run these transformations using different method of starting it. So you can trigger it by an event. For example, you have a Dropbox folder or S3 Amazon bucket. A file can appear there. For example, your supplier sent a new file to you, or just upload it to that folder, and that will automatically trigger the transformation. So it will download that image or send it to Picterra, detect something, get back results, and then you can store it in your database and get all the notification if everything is correct. Of course, before processing your data, you can check whether it meets requirement. For example, you can read images metadata and see whether cloud coverage is good enough, and continue or stop it right there because, well, you don't want to detect clouds probably. Another way of triggering a transformation can be just a schedule. For example, check new data once a week. For example, for Sentinel imagery, you can do exactly that. You can pre-process your data locally with the FME desktop, or if you have cloud instance, for example, everything can happen directly in the cloud. So, and now we can talk about our demos. Our common partner, Picterra, our really great German partner, asked me, I think back in November, whether I updated to new Picterra API. So I created this PicterraConnector, I think 4 years ago, and didn't touch it since then. But of course, Picterra continued developing their platform, adding new capabilities, expanding API, and so I revisited my transformer and decided, to use a scenario-based approach to update. So I wanted to have some nice project to try whatever changes I introduce. I will just discuss a few details about this little project. So I thought maybe I could detect something what is present across the city. It's a city just 300 meters from where I sit right now, the city of Coquitlam. I use their data a lot. It's a very good open data, a lot of layers. So I use it with many different projects for all my tests. So I have this 7.5 centimeter aerial image over the whole city. It's just a fragment, just one of the tiles, and a zoning layer in shapefile. So, and why I need zoning? Because I decided to detect trampolines, the backyard trampolines, but usually people can install them if they have backyard. So it makes no sense to detect in the areas with high rises or industrial, commercial areas. So I use only single family properties and townhouses to run this detection. So, and I mentioned that you can use your data to create detection zones with Picterra, and you can see here on the right bottom this screenshot of 2 images. It's basically the same image, but the number of megapixels on the bottom image is almost 300, and the same image on top has just over 72 megapixels. And that means that when you run this detection, you spend less of your credits. So here is the workspace. I probably will open the real one. So, and for those who are new to FME, here you can see how our environment looks like. I start the transformation and build this transformation by connecting these transformers, which somehow change your data. So, for example, this just begins the transformation. Here I list all the folders or projects that I have, and then I keep just Coquitlam one. That folder or that project where I keep all the images for the city of Coquitlam, and then I bring in a new image and upload it. In here, I bring in all the zoning information. I can just click on this, I stored all the intermediate results called caches. So this is my zoning. I can see it in a table view, and I see that I have multiple categories: multifamily, commercial, parks, single family, and so on. So, and here I clip the whole city of zoning layer to the extent of my image. And at the end, I just run the detection. And as you can see, so I started with a single image here and ended up with 47 trampolines. And here I just add a timestamp, but just maybe to give you a feeling how working with FME looks. I can add, for example, a new attribute here. I will add a new layer, addresses. Those are polygons for multifamily, for single family homes. Those are just basically match to the properties. And I will pass that information where each detected trampoline is on which property it's located. I will add spatial relator. And that will be my supplier of information here, the addresses. And the trampolines themselves will be requesters. And here I will say that my requesters should be within suppliers. I will say, okay. And I will just reroute this link to here. And now I can just add a new attribute. So I will expand it here. So you can see attributes here, lots of attributes related to addresses. And here, some just, intermediate results from detection. But in here, I already have, I have to check this, merge attributes. Okay. I have a combined set of attributes. And now I can just say, add a new attribute, which is, I think it should be plan. Okay. This attribute appears here and it's green. It means that, yes, it will be written. So, and if I run this transformation, I will get an enriched. So I will know basically which properties have trampolines. And now I'm going to show you the results of this transformation. Here they are. My image, I will move it down. My zoning, I will keep only single family. Can you see it? This one. Image. And whatever I detected, trampolines, I will make them stand out, make them brighter. And we can zoom in and check what we have here, whether the detection worked correctly. So it runs about 10 minutes. So I don't want to spend this time during the webinar. I just prepared it a little bit ahead of time. But yeah, it's all true. We can zoom in. Turn off zooming, and I can turn on and off. So as you can see, it all works really great. Maybe now I can go back to my slides here and just show you the result. Is the resulting report I created again with FME. You can read about it here. And at the beginning, I just had only 17 samples, which is really below the recommended number. But it worked quite well. I got accuracy about 90% maybe, but then I added a few more samples, asked Picterra for some help. They recommended me to change one parameter, and ended up with accuracy quite probably above 95%. You can check this report once you get the results, and you will see maybe a couple of false positives. But some detections are really, probably I wouldn't see this one with my, with my eyes. So yeah, really impressive. Second one, which I made in 2019, when I created this transformer, I was really impressed that we can detect cracks on surfaces. It's not even, an object or not even a pattern, because it can be quite irregular. It's just, some. I think Picterra calls it segmentation of the surface. So I tried this myself, and here is my data set. I have a huge image, 160,000 pixels along X and over 80,000 pixels along Y. And here I have another layer of all the paved surfaces in Vancouver International Airport and a few areas of interest. So maybe I should say that YVR runways are in perfect shape. You don't have to, be worried whether it's safe to come to Vancouver. Absolutely safe, but some secondary aprons or maybe taxiways are not that great. So, and I tested my data on there. So I have two workspaces here. The first one just takes the areas of interest and cleaves this huge image to only those areas. In here, again, I can switch to the real workspace. I clip them and upload those small clips to Picterra platform. And here I just select a single detector. You don't have to run this if you know the ID of your detector or maybe even a name. You can just type it inside the PicterraConnector. Just, we'll type a number in here. And then I run the detection and save it to a geo package. And this is it. So, and maybe more interesting is the second part, where I generate all kinds of reports using this, using the results. This workspace is a little bit bigger because, well, it generates real things. But all you have to know here that I measure the area of all the cracks and then bring in the images and all the pavement, the yellow, that you saw, that yellow color on one of the previous slides. Clip again that pavement to the areas of interest, and also measure the area of the pavement within those areas of interest. And that allows me to calculate the percentage, how much cracks of the area cracks occupy. Then I generate with Mapnik some nice raster images where I overlay the image, the cracks on top of each other. And then I generate a couple of reports. I generate an Excel. Those are bookmarks. I can expand them to show what's inside. Well, I try to show off here a little bit, so maybe a few more transformers than it's necessary, but I transpose the table, turn rows to columns and columns to rows. And we can check how the Excel report looks like. It's this one. So I can embed images all within FME into my report, and you can see that this particular area of interest has 5% of its surface is already has cracks, and so on, and some other areas. I also generated a PDF in here. Where I basically specify a multi-page PDF. I basically specify where each block, an image or a title or some numbers should be located on a page, and each area of interest generates its own page. And here is my PDF. Here, I need to move it to this screen. Here we are. Multi-page report. I also here create city work order. So for example, I just run a test. If we have more than 5% cracks, then on the surface, then let's place a work order through CityWorks integration. maybe the last part again about automation. I already mentioned to you that we can start transformations not just by running it manually, but they can run on schedule, and that would be a workflow that you could use. For example, once a week or once a month, run this transformation, check whether you have new satellite imagery. Well, that won't work for cracks, of course, but for some other purposes. With Sentinel imagery, the resolution is too low. Download your imagery. If everything is good, run detection. If not, maybe notify me via email. Once detection is finished, again, if it's a problem, notify me. Otherwise, generate reports and maybe upload them to Dropbox for everyone to check, and maybe notify those who need to know that this process happened. And another one, again, I mentioned that so that something appeared in an Amazon bucket and basically run the same detection. And this is how you design your workflows, your automation workflows with FME server. Again, similar environment where you just connect blocks and change different actions. Maybe one last thing I should mention, if you run Picterra with FME through FME server, you probably would need to change your custom transformer, PicterraConnector, to send requests whether the results are ready through HTTP calls within this environment. It means that basically you don't want to occupy an extra engine while you run the detection. But I didn't implement that in my PicterraConnector yet. We didn't have customers who run this in the cloud yet. But if you are interested, of course, you can always talk to me. I think this ends my presentation, and I can pass this to Lucio.
Thank you, Dimitri. That was fascinating. Some really, really interesting use cases of the integration between the two platforms there. And just as a reminder to everyone, if you do have any questions for myself or Dimitri or anything that Lucio is going to present now, do please pop them into the chat panel. Send them to any questions, ask me, and we'll get around to those questions at the end of the session. But as Dimitri indicated, hand over now to Lucio, who's going to give an introduction to EU SatCen and show how this integration between the two platforms works in a real life use case. Thank you, Lucio.
Hi, thank you very much. Next slide, please. I work at the European Union Satellite Center. Just a short introduction about the EU SatCen. Basically, we provide timely relevant, accurate geospatial intelligence joint products to European Union member states and other organizations. So we just provide the value-added product and services, and so solution, not only data. Next, please. We are an European Union institution, so you will see in a while how it is organized. But basically, our mission is to support the decision-making and action of the European Union in the field of common foreign security policy and common security defense policy, exploiting the space assets, and this is basically our main organization. So we have an operation division, capability development, IT, where I am, admin, and finance. Next, we are 150 staff, civil composition backgrounds. Next. And basically, we were built in 1992 as WU, Western European Union. And then in 2002, we moved to a European agency. Then there are several treaties that are the one that regulate, how to say, organize the activity of the SatCen that are available there during the years. And last year, we had the EU Strategic Compass, that is the one that is moving us to the next steps in the European Union organization. And we just last year celebrated 30th anniversary of the SatCen. Next. So basically, as I said, in the Council of 2004, we are organizing this way. We have the Council of the European Union, and then we have the representative political security committee, the board of the SatCen, and the SatCen itself. So basically, we have a complex architecture in which we have the different elements of the European Union acting and supervising our guidance and our operational activities. Next. Basically, is what I said. We are based with this areas. So we have geospatial intelligence, IT, training, and capability development. Next slide, please. These are the main partners of the European Union. So basically OSCE, United Nations, and External Action Service, Copernicus, Frontex, and so on. So we provide a lot of product and service to all these agencies and entities. So our portfolio is quite varied and complex. Next, please. What we use, as I said, the satellite imagery mainly. As you can see from this slide, the number of satellites and the product is always increasing, and it will increase more in the near future. So the need for having appropriate tools and meaning to handle this immense workflow of data and services available through all the satellite and constellation is quite important for SatCen. Next. For this reason, as considering also that we have to provide product to high decision maker up to the field, is quite complex for us to manage all these things all together. So what we have to do is try to force as much as possible a streamline workflow in order to harmonize all this information and to be able to provide a portfolio of services and data as good as possible for all these decision makers. Next slide, please. We are involved in crisis management all around the world. So we have some examples from Mozambique to Mali, Frontex for illegal immigration, United Nations support. Next. And also we work with the Copernicus in the Copernicus project, in which we have a strong connection with all the activities in the Copernicus area. So the idea is the project here are based on several levels, from support directly to SEA, SatCen and enterprise entities providing services to SEA Copernicus, and also to CBS, the support to Frontex. So we have, as I said before, quite complex geometry to provide services to all these projects and activities. Next. By the way, we have also some training activities. We have some courses you can see in the webpage of the SatCen, dealing with from joint to SAR to IMINT to industries to nuclear activities and so on and so forth. Next. And just to finalize the introduction, as you see, as I said at the beginning, this 2022 strategic compass for the SatCen provides 4 key priorities for the strategic mode. It is ACT, support to external action services, secure, support to resilience and preparedness, invest and develop in-house capability that we are always doing, and to support partners like United Nations, SCE, and PCW. Next. So this is the center always been built and evolved in the last 30 years, some historic feature to represent the evolution of the SatCen during the years here in Spain. Next slide. And now we go to the part that is more dealing with the standardization. It's more than 20 years that we are partner of the Open Geospatial Consortium. I know if you know it. And this gives us the possibility to work a lot on all the area of geospatial management of data. Next. I will present now, with agreement of the OGC, 2 main domains, that is the geo artificial intelligence and training data markup language for artificial intelligence. Next. These are 2 recent developments of OGC. As I said, SatCen is committed to produce value information, so we are expecting what is the fair, findable, accessible, interoperable, and reusable approach of OGC. And to do this, we have sort of accuracy for spatial. We need to take into account the quality aspect of services and data, that is accuracy, consistent integrity of data, completeness, semantic interoperability as much as possible, and scale, spatial reference system projection harmonization. So these are the main approach inside the OGC, and the SatCen is committed also to do this. Next slide, please. To do this, what we did is to work with other institutions and trying to establish what is called the common data model, and to define what is called our data dictionary. So so basically what we did was to try to define our common data model and to have all this common framework to enable the integration of application and data at SatCen. So we defined this in the last years, and now we have quite proud to have managed to have a common data model that is quite working and useful for the SatCen and member states. Next slide, please. Going back to OGC, we have the GeoAI domain working group. Here I am. So what we have here in the last meeting in February at OGC in Frascati, European Space Agency, we had the nice and interesting discussion about the GeoAI, and we have all these kind of things that are going to be, how to say, discussed, and we had at the end the opportunity to have two main working groups. One is domain working group inside the OGC framework, that is the GeoAI domain working group, that will deal with data standards, quality ethical standards, model interoperability, performance, and security. And this is something I will really enjoy that people will enjoy joining and participating and commenting, because it's quite interesting as a working group. Next. And then we had an interesting discussion and a presentation of the training data markup language for a standard working group from Peng Yui professor, sorry for the pronunciation. And by the way, it's 4 days that this document is available for public comment on the web. So just type the name of the document and you can download it. Next slide. The main issue here is to have for the training data and all the activity connected to artificial intelligence, something that is important to understand and to outline is that we need all this information somehow managed and following some standards for several reasons, for data model, data privacy, data services, and other activity that we will see in a while. Next. You have available on the net a lot of training data set for scene classification, object detection, land cover, land usage classification, chain detection, and so on. Next slide, please. But for the data model, we should have something that is typically something that we should consider. That is basically core elements, the core information, granularity of the data, label semantic, provenance, and all the other things you see there. So basically the idea is to have the standard based as the other OGC standard with the core part with the basic component, and the other part of the standard based on different items like quality, provenance of data, and so on. Next slides. These are also important aspects. So granularity of the data for the artificial intelligence trained data set and trained data. Sorry, yeah, I'm in an open space, so there is some noise here around. And the provenance of data also is something that we can have to consider important. Next slide, please. And the quality of the information itself of the data. So all these things make us possible that when we train the model and we have some result, we have valid and result that are valid and they can be repeated in the time. So it's something that we have to support all the activity inside the artificial intelligence machine learning processes. Next. As you see, are some other elements, but I strongly recommend you to go directly to the original document, in which there are some UML abstraction for all the item we see here and the data model itself. And next. One of the nice part of this is that there is a lightweight design for the standard. This is a standard again for the training data model and quite extensible. So we are able to include the other element of the composing building blocks of the standard in the next steps of the process of the standard evolution itself and during the usage of the data. Next. As I said, that this is the modular part of the standard. As you see, the basic part that is the training data set, training data, training task and labeling, and also the other part that are quality provenance and change set. All these things all together give us the possibility to have very nice and reliable data sets and training data. So we are able to run our model and in a better way compared to what is done up to now. Here you see crowdsourcing project like OpenStreetMap is used where the changes set is used well. This is because this is important for us because we are using a lot of OpenStreetMap data in our process, and this is what raised me the idea of trying to fuse Picterra and FME in a real scenario, in a real use case that we'll see in a while. Next, please. These are also ethical principles to use when we are dealing with this kind of data. No need to repeat, but we need just to have data set to serve just the purpose. So for clear need, primary stakeholders should be engaged in what is the lifespan of the data set, the quality and inclusivity of the data set, and the data set must be open and transparent. Next, please. Some issues for the data service. Here we have to consider that all these, as we have seen before with the imagery presentation, we are moving towards something that is more a workflow where all these things are integrated. So what we should go forward, we should look forward is to have a sort of AI-ready spatial data infrastructure. Here are some examples, but the idea is to work all together to have a sort of unified data model so we can implement this better and better. Next. Here we have our main workflow in which we have to deal with geospatial data. So we are, as I said before, we are integrating open and commercial vector data, and then we add, we create added value product, and then we store and disseminate. As you see here, we have internally developed tools. We use AI FME, spatial, Picterra, QGIS, whatever, name it. And the idea is to have in the workflow the possibility to integrate all this information in a sort of seamless and integrated approach. Next. The example we were running with Picterra and FME was based on open image, in this case a Google image of a Spanish airport. And the idea was to detect and to identify local roads to increase to enrich, how to say, how to update the information coming in OpenStreetMap. Next. After the running of the example, you can see on the left-hand side the vector-based layer, the information there, and on the right-hand side the detected local roads. Now here we have several problems and items to discuss. When artificial intelligence or tool like Picterra detect things, normally you have an area. So it's not really it's not still a line or a road represented in a proper way. So what we did here together with FME was to convert this area in a line and assign to this line attributes as much as possible to detect and to identify to enrich the information there. But not only, we were able to run also topology on top of this, so to connect the different layers, the different lines and of the roads, and to create a network of lines. So basically, this gave us the possibility to check, to compare this information automatically extracted with the original OpenStreetMap data, so to enrich the original data set or to update the original data set. And basically, I think this is the last slide. Next. Yes. So basically, what we have done here was to try to automate as much as possible the usage of this tool for integrating and enriching a common available data set like OpenStreetMap and things like this. But the important stuff here is that all these things should be managed following as much as possible geospatial standard or any other standard that will come out. Thank you very much.
Fantastic. Thank you, Lucio. So now is the time of the webinar when we come to questions. So based upon our presentations that you've seen during the past hour, please do pop any questions that you may have into the chat panel. I see we've had a few already, so we'll dive into them. So I can see actually one for me. So one here that's asking, does Picterra and SAFE support multispectral imagery? So yes, that's an easy one. The answer is yes. So we're able to process both optical RGB imagery and multispectral imagery, which includes things like false color images, thermal images, SAR, SAR imagery, NAR, and height maps. And actually, one of the cool things we've done recently is the introduction of NDVI analysis. So you can actually quickly create a false color image that represents the normalized difference vegetation index, which is very useful in understanding vegetation density and assessing changes in plant health, for example. Okay, I'm just looking at the next question. It's a question for Dimitri. So does SAFE Software FME provide or support a connector to some satellite imagery providers to get access to image archives or task new images?
Yes, we can. We have a reader for Planet and Sentinel, and then well, some of them, for example, Landsat, you can download directly as TIFFs, and I also made some example workspaces where you just click on an area or supply a vector layer, and we download that for you. So yeah, there are various ways of getting to the data. So either through direct readers or through some built workflows.
Okay, perfect. And got another question around how long it takes to train a machine learning model to do some of the detections we've seen during this presentation. So the roads, for example. And I think someone asked about road detection. Yes, that's correct. So actually the great thing about the Picterra platform is that this kind of detection and being able to detect at scale is very quick, 95% faster than traditional methods. And we're looking in the order of about 20 to 30 minutes of annotations, in which you need surprisingly little to be able to have a very high accuracy score when you're then scaling up to, say, city or even country level based detections. I'm looking now. So I think there's another question for you, Dimitri. So once your results are obtained and a PDF has been generated that you showed us in the demo, could FME then send an email to someone with that PDF attached, or a group of email addresses?
Yes, absolutely. You can do it directly from FME desktop. You have another transformer, like you saw a lot of them today. There is an emailer transformer that can do that. And I already showed a couple of diagrams with FME server, where it will be another block. Again, you configure it, and an email will be sent to the whoever you need it. And of course, you can include attachments. So it can be just anything. Your results can go to your email.
Okay, perfect. It's a great way to share the results. Looking now. So another question would be, does Picterra offer some tools or techniques within the platform that can help improve the accuracy of a model? Okay, good question. So yes, so once you've started to train your model on whatever it is you're trying to detect, you'll obviously want to try and improve the results, the accuracy score that you're receiving. And often it would be quite hard to actually determine, well, where should I start to iterate on my model to improve that accuracy? Where are the best areas within my imagery to add training areas, to add annotations, for example? So one of the things that we've introduced is something called the dataset recommendation report. So this allows a very quick assessment of the training coverage you have already, and actually very intelligently identifies areas where you should concentrate on future iterations to improve that accuracy score. Actually, it was one of the things that's great to try in the demo. So again, if you go to picterra.ch, sign up for a free demo, you can get access to that functionality. Okay, let me just go through any more questions that we have. So one question is around, are the ML models shared openly? It's a good question. So within an organization, you can have many shared accounts within one organization, and the models that you're creating can be shared very easily within that organization. So within colleague to colleagues, for example. We have some great collaboration features, in fact, live collaboration features, where you can start to work on the training imagery and data sets in a live view, so you can see whatever people are doing to ensure consistency within that training, which is very important when you're training a model such as this. Just check to see if any questions that we've missed. Nope, I don't believe so. I think that's all the questions. If you do have one, please get it into us now, or we will follow up with questions that we may have missed during the next day. So final slide, please, Dimitri, if you would. So all that remains is to say a big thank you to my co-speakers today, to Dimitri and to Lucio. Big thank you to everyone that's participated today and indeed asked a question. You will receive the recording of this webinar within your email in the next 24 hours. The slides as well, which have all the links embedded. So all the links that Lucio shared, for example, you'll be able to access directly, and all additional resources such as the demos that Dimitri went through as well. So please do check out our website, our various social accounts. If you're interested to know more, please request a demo, and I'll see you in the next webinar. Thank you both. Thank you, Dimitri. Thank you, Lucio.
Yeah, thank you, everyone.